Hello guys, my name is Diego Pacheco and this is another Java video. Today we will be talking about Java 15 or JDK 15. So the JDK um, became available yesterday, 15 September 2020, and today I want to go through some of the features. There are a couple of features that are very interesting and very promising. So let's get into. So basically, here are some resources that I'm gonna share later on the blog post, right? So here you can go and download Java 15 or JDK 15. It is a very interesting release. There's a lot here, and there's a lot to unpack actually. So one cool stuff is about cryptography. There is this GEP called 3039 Edward Curve Digital Signature Algorithm, EDDSA, which you can look on the JEP 339. This is for asymmetrical encryption. This is really interesting. Also, it's a standard security thing. So you know you can take a look on the RFC. There is an RFC in security for it, like this one. I mentioned this. So it's a signing algorithm, right? That you can sign. Also, there is the evolution of a preview features we saw in JDK 13 and 14. For instance, there is the pattern matcher for StanceOff that's in the second preview, records the second preview, text blocks on the second preview, and we also have sealed classes and interfaces, which is awesome feature. I'm gonna show you guys some demo. And there's something on incubator called FMA, foreign in memory access, which is very, very interesting. And also we have the ZGC. I think this was developed by 5 years or something in development. It was a long time to go. And this GDC promises GC pauses not extending 10 milliseconds. So it looks very exciting and the performance look very cool. So in order to enable, you need to pass this parameter to the JVM. It's really interesting. I really recommend you to take a look. Now let's take a look on the code, right? So I have a project here. I already downloaded the JDK 15s on my Java home. I have both working with Maven and with IDEA. So let me show this running with Maven first, so you can see it works, and then I also have with IDEA. So let's start with the build part. In Maven, you need to set the compiler plugin, and then you need to set the source and the target to 15. I also enabling preview for the preview features, and this is actually not needed, this part here, because this we are doing with a Java module, and I can show you all by building again. You can see it works, right? So let's look the interesting stuff we have here. Lots to unpack. So first of all, the FMA, right? So now we can directly access memory. So you have this memory segment where you can allocate, right? So we are doing allocate native, and we are allocating 10 bytes. So we can do some low-level programming with Java right now. Then with that segment, you can get this byte buffer, you can get the memory. You might want to do that on a try block, so it makes sure it's closed at the end, or you explicitly can call close, right? So if if I run this way, you're gonna see it works. I get the warning because I'm using an incubator feature, right? And then you can see it working. This is great for performance in low level access. In order to this to work, if you try to run this code, when you do the import here, it will not work. You need to have this module /info.java, where you need to require the JDK incubator for engine, and then it works, right? So that's important. Now let's go to the cryptography thing. So basically, I'm gonna generate a key pair, right? So I have a key pair, asymmetric encryption, and then I can use the weather curve to sign something. I can sign a jar or sign a message. So here I'm having this message, hi, this is a message, and then I'm signing that. And here I'm using the EDSA, the Edward Lipton curve algorithm, and also I have a public key, and I'm generating that public key. So let me run this code. You can see here it works. Now the most interesting thing. So now there is local, there's this local interfaces, local classes, and local enums you can do. So for instance, you see I have this main method where I define the interface inside of main, and also I'm defining a class inside of main, and also I'm defining an enum. That was possible to do in other languages like Scala and Python, and now it's possible to do in Java. And that's really great for encapsulation and hiding, right? That's a very, very cool feature. Now let's go to the best part for me, the sealed classes and interface. This was copied from Scala, but I think this one is a bit better. So now, when you define classes and interfaces and records, you can tell them if they are sealed, non-sealed, or final. So if I say sealed, it means they are closed, and I don't allow anyone else to interfere on the inheritance. So here I have a plant. This is the IntelliJ IDEA example. And now you say permits, and then you say exactly what classes can be part of the inheritance, and what classes that are not here cannot, right? So you see I have a final class, which is a herb, which is final. It can be part of the hierarchy. I have a sherb, which is non-sealed. It means you can extend sherb, but you cannot extend herb or plant. And there's a climber, which is sealed, but it permits cucumber, right? So as you can see, you can use permits on every piece of the hierarchy, and you can tell how further it can be extended or not. So for instance, let's say if I create a class called evil here, and let's say evil wants to extend plant, you're gonna see this code does not compile, because evil is not allowed in the sealed hierarchy, right? And that's really great. This is so great for many reasons, but to create better abstractions, to prevent information leakage, that's really great. So here's another example I create. This personal example. So I create a sealed public interface called rock. And then I'm saying that rock allows rock record. So I can have a rock record. And rock record is a non-sealed interface. So you can see I'm using two interfaces here. So rock record extend rock and no seal. And then I have a record, is a Java record, where I have sit anger, so I was listening to Metallica, so that's why. And I have a ear, right? And basically I'm saying this implements rock record, and that work because the interface is non-sealed, and even a record can implement it, right? Which is pretty cool. So now let's say if we define interface called Samba, Samba is not allowed to implement rock for obvious reasons, right? Because rock, it is sealed. But I have another interface that I call SNM2, because I was listening to Metallica a lot nowadays, and this extends rock record, because rock record is non-sealed. That's why I can do it. But for instance, Also, I can try to do this, right, and say, okay, SM2 extends rock, but I cannot do that because rock is sealed, right? So I can't do this. So this is good. You have control over every class of the hierarchy. This is really great feature. So one last thing I need to show you here. If I press Ctrl Shift Alt S, right, and then I go in project, IDEA needs to be running on Java 15, and also here you need to point your JDK 15, and on the language level you will need to pick here 15, right? And that's how you do in order to work. And then if you do that, you're gonna have the autocomplete, like seal, non-seal, like here. If I do Ctrl space, you can see IDEA, it recognizes also for non-seal, right? So that's a very good thing. I'm really excited about the next releases. Java finally is looking promising again. So that's it for today. I hope you guys like it. See you next time. Cheers.